All right, let's get into it. Today, we're talking about one of the most critical dials you can turn when you're training a machine learning model, the learning rate. It's really all about finding that perfect sweet spot between getting your model trained up quickly and, making sure it actually learns something useful in the process.
But before we can even talk about the learning rate, we've got to ask a more basic question. When we say a machine is learning, what's really going on under the hood? Well, you can think of it as a process of trial and error, but a very, very smart and guided one.
I want you to imagine something. Picture yourself standing on a huge, hilly landscape. The catch? It is completely blanketed in a thick fog. Your mission, should you choose to accept it, is to find the absolute lowest point, the very bottom of the deepest valley. But here's the trick. You can't see the whole map. All you can do is feel the slope of the ground right under your feet. Believe it or not, this is the core challenge of training a model.
Now, in the world of machine learning, this foggy landscape has a proper name. It's called the cost function. It's basically a mathematical map where every single point represents a different version of your model. The altitude at that point? Well, that tells you how wrong, or how costly, that model's predictions are. So the goal is super simple. Get to the lowest possible altitude. Find the minimum cost.
So you're stuck in this foggy landscape. What's your strategy? It's pretty intuitive, right? You'd feel the ground, figure out which way is downhill, and just take a step in that direction. And then you do it again and again. This simple process is exactly what an algorithm called gradient descent does. It just calculates the downhill direction and takes a step to make the model's error a little bit smaller.
But see, this leads us to the most important question of all. If your only move is to step downhill, well, how big should each of those steps be? This one single decision can literally be the difference between a model that works and one that completely fails.
And that step size has a name. You guessed it, it's called the learning rate. This is the specific setting, the hyperparameter, that tells our model how boldly or how cautiously it should navigate that foggy landscape on its journey to find the point of minimum error.
So to get technical for just a second, the learning rate is a small number. And what it does is control how much we adjust the model's internal guts, its weights, after each guess it makes. A bigger learning rate means we make a bigger adjustment. A smaller one means a smaller adjustment. Simple as that.
And this brings us right back to our analogy, which I think makes it so clear. Are you taking giant, confident leaps down the side of this mountain, or are you taking tiny, careful little shuffles? That stride length is your learning rate, and it totally changes how this whole journey plays out.
So what happens when that stride length isn't just right? Well, this is what we call the Goldilocks problem. The size of your step matters a lot, and getting it wrong can lead to some really big trouble.
Okay, first scenario. Your learning rate is way too large. You're taking these massive leaps down the hill. What happens? You might step right over the bottom of the valley and land way up on the other side, maybe even higher than where you started. Your model's error is just going to bounce around like a pinball, totally unable to settle down and find that stable solution. We call this oscillation, or even worse, divergence.
Now for the opposite problem, a learning rate that's way too small. Now you're taking these incredibly tiny, super cautious shuffles. I mean, you are guaranteed to be going downhill, that's for sure, but your progress is going to be painfully, painfully slow. Training could take forever, or you might get stuck in a little flat spot, thinking you've reached the bottom when the real valley is still miles away.
And finally, we have the just right scenario, the Goldilocks zone. With a good learning rate, the model takes these confident, efficient strides. It walks down the cost function landscape quickly and smoothly, finding that minimum error in a totally reasonable amount of time. This is the sweet spot. This is exactly what we're aiming for.
So you can really see the core trade-off here, can't you? If you try to go too fast, you risk breaking the whole learning process. But if you go too slow, you might never actually get to your destination. The whole game is finding that perfect balance for efficient, stable learning.
Okay, so that all sounds great, but how in the world do we find this magical just right value? Well, while there are a lot of super advanced techniques out there, there's a really simple, practical approach you can use to at least get yourself in the right ballpark. So where do you even begin? Here's a great approach. First, just pick a common starting value. Something like 0.01 is a classic place to start. Second, let your model train for a little bit, not too long. Now, the third step is the most important. You're going to plot your model's error over time. Just make a graph. And finally, step 4, you just look at that graph. Is the error dropping nice and steady? If so, you're in good shape. Is it jumping all over the place? Your rate is probably too high. And if it's barely moving at all, well, it's probably too low. And from there, you can start to tweak it.
So as we wrap up, let's just bring it all back to that central idea. Choosing a learning rate is all about managing this one fundamental trade-off, the speed of your training versus the stability of the learning process.
You want your model to learn fast, of course, but you don't want it to learn so fast that it completely fails to learn anything at all. It's this delicate balance that really makes picking a good learning rate both an art and a science.
And that kind of leaves us with one last fascinating thought. So far, we've been looking for one perfect constant step size. But what if the size could change as we go? Imagine taking big, confident leaps at the very beginning when you're high up on the mountain, and then taking smaller, more careful steps as you get closer and closer to the bottom.
Well, that idea right there is the key to a whole world of more advanced techniques, but that's a topic for another day. If this explainer helped you get a better handle on the learning rate, please do us a favor and like, share, and subscribe for more deep dives. Thanks for joining me.